Welcome back, students. I want to talk today about transformations of quadratic functions. So I've set up this Desmos graph for that very purpose. Right now, what we see is the parent function, x squared. Now you'll notice that's f of x, and then g of x provides all these different types of transformations we can apply, such as multiplying a number to the function of f, or multiplying a number to the input of x inside of the parentheses, or adding or subtracting some number to x inside of the input, or adding some number outside. So we're going to move around these sliders and see how all of them affect the shape of the graph. Okay, so let's start with k. So as I move k, we can see where the parent function used to be. And if we're adding a 5 inside of here, inside of the input, so if I'm adding 5 to the input, notice, or sorry, this is k, we're adding it outside. We are adding this to the output. So this is moving everything up and down. If I add a 5, it goes up 5. If I subtract a 2, you'll notice it goes down 2. So fairly straightforward thing that does. Now let's look at h. So as I move h values, notice how that is changing. Okay, so if we are adding a positive 4, notice it takes us all the way back to negative 4. Now, the reason for this is, remember, this is happening inside the parentheses. This is happening to the input. So if I'm adding a 4 to all of my inputs, that means all of the outputs that it used to give are going to happen 4 places sooner because we added a 4. We made all of our inputs 4 bigger. So all of those same outputs, the values on the graph, they're still showing up, but they're showing up 4 places earlier. So if you add a 4, it'll take you to the left. If we subtract it, makes everything happen later. So if I subtract a 5, notice it moved it 5 places to the right. Okay, let's now look at how our different multiplications will work. So first, let's just change this a sub 2 where we are multiplying on the inside from a 1 to a negative 1. And you'll notice we don't really see any difference. And that's because what that does is create a horizontal or a reflection across the y-axis. Well, this is the same on both sides. So if you reflect it, you're just reflecting it onto itself. However, with a1, when we're multiplying to the output, to the outside of the function, and we change that to a negative 1, this one creates a reflection across the x-axis. All right, now let's go ahead and multiply it by 2. All right, so something to notice. At 1, this one was at 1, but this one is at 2. At 2, this one was at 4, and the transformation is up at 8. Everything is twice as high. It got vertically stretched by a factor of 2. If we take it down to a half, you'll now notice everything is half as high, where the black one, our parent, was at 4, the child is at 2. Everything is half as high. This is a vertical shrink by a factor of 1/2. So that's if we're multiplying the output. What if we multiply the input? Okay, so it looks kind of similar, but notice we're not just twice as high anymore. There's a bit of a difference here. Instead, think horizontally. Whereas this one was out, where x was a 1, the child is now at 1/2 right there. Out here, where x was 2, this is at 1. Out here, where x is 3, that's at 1.5. So by multiplying by the inputs by 2, that has decreased it horizontally by 1/2. And if we were to multiply by 1/2, notice this one went out to where x is 1, but then that's at 2. Where x was 2, this one is out at 4. Where x was 3, that's out at 6. So it stretched it horizontally by a factor of 2 when we multiplied by 1/2. So now that we've seen these, let's take a look at the notes and start working on those. Now your notes contain a little reminder of how each of these work. Horizontal translations, notice that's where we're taking our function f of x, and they put it as minus, but essentially all you need to remember is if we are subtracting a positive from x, that's going to move us to the right. If we are adding a positive to x, that's going to move us to the left. Just remember, would it make it happen sooner or later? Vertical translations, where we're adding some number to the output of f of x, and that'll move it up and down. If you add a positive, it goes up. If you subtract, it goes down. All right, so this one wants us to describe the transformation of f of x squared represented by g of x. So we are going to graph f of x is equal to x squared, and its transformation that is represented by g of x, where we got the quantity of x plus 4 squared minus 1. And then we're going to graph each. So let's first look at each of those. So first, notice how we're adding a 4. And notice where it is. It is inside these parentheses. So this used to be x squared. For it to be in there, we must have done f of x plus 4 in order to get it like that, so that rather than just having x squared plus a 4, this is an x plus 4 squared. So it being on the inside makes a difference. That tells us this is going to be a horizontal transformation. So it's going to go to the, so a translation 4 to the left. Okay, next we got this minus 1. This is happening outside of that. So to do that, we'd have something where we've got like an f of x minus a 1. We're just subtracting from the output. So this is going to create a translation that goes 1 down. All right, so we've described the transformation. Let's go ahead and graph these now. So we're going to start off with the parent function. So a normal quadratic when, so let's see, at 1, oops, that should be higher. 2 squared is up at 4. And this is going to be symmetric. And then 3 squared should be 9. 5, 6, 7, 8, 9. All right, there is our parent function. All right, let's do the child function now. This is going to have all of those points going 4 to the left and 1 down. So 1, 2, 3, 4, 1 down. 2, 3, 4, and 1 down. Okay. And so every single one of those. So you'll notice it's pretty much the same graph. We just took each of our points and moved them 4 to the left and 1 down. We could go ahead and use a calculator and type in the values. So saying, well, what if x is a -3? Where would that be? And we'll find that these are the values that we would get. Okay. All right, now let's look at the reflections. Notice how they're showing again how if you change the outputs to negative, that creates a reflection of the x-axis. If you change the inputs to negative, reflection across the y-axis. And since this is symmetric, just goes on to itself. A stretch and a shrink. If we multiply the input, then that's going to create either a horizontal stretch or shrink, depending on if the value is a fraction or if it's a larger number than a 1. Okay. Remember that it will be a horizontal stretch or a shrink by a factor of 1 over a. And in fact, so I'm going to write that right there. This creates a factor of 1 over a. It stretches by 1 over a or shrinks by 1 over a. The vertical stretches, these will happen just by a factor of a. So if you multiply by a number bigger than 1, it'll go higher. If you multiply by a number between 0 and 1, it'll shrink. Okay, if you multiply by a fraction, it'll shrink. All right, so let's go ahead. Looking at these, we are once again going to graph our parent function, and then we are going to graph the transformations of the parent. Okay, and we're going to describe what kind of transformation it is. So in this one, we are multiplying it by a 1/2. Notice it's not inside of the x squared. It's just we took the x squared and then we multiplied by a -1/2. So there's two things there. There's multiplying by a negative and multiplying by a half. So let's deal with the negative first. That negative is going to cause us to have a reflection off the x-axis. Then multiplying by a half, because we're multiplying the outside, we are multiplying the output. That means this is going to be a vertical shrink or vertical compression. By a factor of 1/2. Okay, so there we have. Does not want to change colors for me. So we're going to go ahead and do that one in red. So first, if I reflect this off of the x-axis, it's still in the same place. Shrinking a half by a half is still a half. Okay, the 1, we reflect it down to a -1, and then half of that. 4, reflect it down to a -4, and half of that. 9, reflect it down to a -9, and then take half of that. Okay, And we'll do the same on the other side. And there we go. So we can see it's a little bit wider. It did have that vertical shrink happening in there. Okay, next. We've got this +1. That one's just going to take us up 1. Notice this time we're multiplying on the inside. So this one is going to cause us a horizontal stretch or shrink. Because it's a number bigger than 1, this is going to cause us a horizontal shrink. By a factor of, and with the horizontal stretches and shrinks, it happens in terms of 1 over a, so by 1/2. So it's going to shrink inwardsly by 1/2. So with each of our points from the parent, we would move them up 1 and then horizontally shrink them inwards. Now 0 isn't going to shrink inwards, but we can take this one where we're going to move it once again up 1 to a 5, and then it's out at 2. We're shrinking it inwards by 1/2 to a 1. Up here at 9, we're going to move it up to a 10, and then since it's outwards at a 3, we're shrinking that in half to where it's 1/2. And there we go. So when you are stuck and you're not quite sure exactly how to make the graph, don't fret it too much. Make yourself a table. Give yourself some points to calculate. Put these numbers in for x, check what it gives you. If you don't have enough points, do some more. Grab some more numbers. But don't allow not exactly knowing how to do the transformation stop you from moving forward with your graph. But after you've done your graph that way, go ahead and check. How did that move? How does that relate to what you've learned about these transformations? And if you do that whenever you get stuck, you're going to understand these a bit better. Hope this helps. Good luck on your practice.